Welcome. In this video, we are going to discuss about the previous year NEET question in NEET 2026 under the topic of atomic structure in physical chemistry. It involves quantum chemistry also. Atomic structure and quantum chemistry are all same. Okay, let's discuss. Consider the following schematic plots of orbital wave function. There are four graphs are given, which means four plots are given. The figures representing two radial nodes in the orbitals. Which figure represents the two radial nodes? This is a question. How to identify the nodes from these plots? There is always a one way to find out these type of answers. In graph, there is a one virtual line. Always there is a one virtual line. In the four option, it is given. There is a virtual line, there is a virtual line, here it is also a virtual line. There is no virtual line in this case. Okay, always there is a virtual line. Okay, a line above this virtual line have one sign. I am take the sign as a positive charge. Below this line have negative charge, negative sign. So if a graph goes like this, from plus to minus, which means a line goes up to down, which means a change in the sign happen. Node is nothing but changes in the sign, which means this type of line have one change in sign, which means one time change in the signs, plus to negative, right? There is a one node. This is a way to calculating the node. How many times a wave changes its sign in the plot? In the option A, there is a no virtual line, so it does not contain any nodes, or else it do not represent the any node. In the option B, look clearly. In the option B, there is a one wave goes from positive sign to negative sign. There is a one time sign changing, so there is a one node. After that, there is a no change in the sign. It resides in the negative parts. It can it go it, which means it didn't go to the positive parts, so that it contain only one node. Okay, in C, the wave starts from the positive side to the negative side. There is a sign changing in one time. After that, this wave goes from this negative parts to the positive part. Okay, so there is another change in the sign. So 1 plus 1 is 2. After that, the wave resides in the positive part. So 1 plus 1, there is a 2 nodes. So basically option C has 2 nodes, which means option C has 2 nodes. So this is the answer. So the third plot, this is A plot, this is B plot, this is C plot, this is D plot. So the third plot has the node of 2, because the wave changes the sign 2 times, consecutively 2 times. The consecutively is also important, consecutively 2 times. So the option is answer C. This is a way to find the number of nodes from the given plot. This is a very important one. Okay. This is the next question. Choose the correct answer from the given options. Okay. This is a list 1. This is a list 2. We need to match list 1 with the list 2. List 1 is given as a quantum numbers n and l value. N means principal quantum numbers, L means azimuthal quantum numbers, as we know. Okay. In list 2, that is orbital is given. Okay. Principal quantum number, which means it is very easy. One is principal quantum number is 1. For 6f orbital, principal quantum number is 6. The number before the sp-df orbitals, the number before the sp-df orbital is called as the principal quantum number, which means 2. If your value of n is 2, it's supposed to be 2s, 2p, 2d, or else 2f. Okay, so 2 is corresponds to 2p, 4 it corresponds to 4s, 5 it corresponds to 5f, then 3 corresponds to 3d. Okay, so A comes for second option, B comes for third option, D means, sorry, C, right? C. It is not D, it is C. C comes for fourth option, then D comes for first option. From principal quantum number alone, we need to consider the azimuthal quantum number also. Okay, azimuthal quantum number also. So I'm considering this now. Okay. For s orbital, principal quantum number is 0. Sorry, azimuthal quantum number is 0. For s orbital, azimuthal quantum number is 0, which means L value for s orbital is 0, p orbital is 1, d orbital is 2, f orbital is 3. This is from the quantum mechanics or else atomic structure. So 1 corresponds to p, right? 0 corresponds to s orbital, 3 corresponds to f orbital, then 2 corresponds to d orbital. This is also results in the same. A is for 2, second option, B is for third option, D is for fourth option, then A is for one option. So this also results in 2, 3, 1, 4. 2, 3, 1, 4, which means the option B is a right answer. So from the principal quantum number and azimuthal quantum number, we found the answer. This is a way to solve this type of questions. Okay. Let's see the next question. Okay. A bulb is rated at 150 watt, converting 8% energy into light. If the energy of one photon is 4.42 into 10 to the power minus 19 joule, how many photons are emitted by the bulb per second? Okay, basically a bulb is rated at 150 watt. Watt is nothing but a unit of power, which means power is equal to energy per time. Simply the unit is joule per second. So the 150 watt is nothing but 150 joule per second. Okay, 150 second. If we convert this watt into energy, it is very simple. Energy is equal to power multiplied by time. Power is nothing but a 150 watt. 150 watt means 150 joule per second. So time is nothing but they are asking how many photons are emitted per second. So multiplied by 1 second. Second per second get cancelled. So energy is also 150 joules. Power is also 150 watt. That's it. We found the energy. Finally, we found the energy of what is called energy of the bulb. They gave power of bulb. I am converting it into energy of bulb. Okay, let me erase this. Okay, this is a simple conversion. So I am done quickly. Okay, energy is nothing but 150 joule is also energy. Okay, out of 150 joule, only 8% of light is converted. So we need to find the 8% of 150. It is very simple. 8% is equal to x divided by 150 multiplied by 100. If you solve this, which means this 0 get cancelled. If you solve this, you will get x is equal to 12. Okay, 8 multiplied by 15, then divided by 10, it will give 12. Out of 150 joule, only 12 joules are used. Only 12 joules are used. I must know in 12 joules how many photons are there, because only 8% of electrical energy is converted into light. So that 12 joules contain how much photons, that is my answer. But I want to know the number of photons. What is the way to find in 12 joules there is a how many photons? There is a one way. If you divide 12 joules by the energy of one photon, because 12 joule is nothing but the energy of total photons. This is energy of one photon. If you take the ratio between energy of total photon and the energy of one photon, you will result in the number of photons, right? 4.42 into 10 to the power minus 19. Energy of total photon, energy of one photon, joule get cancelled. You will directly result in the number of photons. If you divide these two, you will get 27.2 into 10 to the power 19. So this much of photon is present in the 12 joule of energy.